Right, so moving on to example 9, having missed out example 8. First thing we need to look for this one is to think about what concepts from mechanics we're going to use. So it tells you in the chapter it's about forces, and that shouldn't be anything that's too surprising given some of the words in the question. This is really important. This fact it uses constant word. So that means that the A is going to be constant as well. Constant acceleration, which means we can use SUVAT. We can use integration and differentiation when it's constant. It can't be done the other way around, but it's always just easier if it is constant acceleration to use your SUVAT equations. So we need a force at the end of the question. So I'm going to use F equals ma, but because I'm doing the force at the end, I'm going to need the A first, which means I'm going to need to use SUVAT first. Okay. So it says here at time 0, this is the velocity, at time 4 is that. So effectively, this is the U. I have the S here at time is 4. So my S is 16 and -4. My U is the time at the start, so -2.5. My V, it looks like we don't know. The A is what we're looking for. And the time, well, we're using this at 4 seconds. It's the displacement after 4. So time is going to be 4 at that point. So I'm looking for the equation without V. So it's the one we've used a few times and it's quite common. S equals ut plus half at squared. So I'm just cram this at the bottom of the page and not turn over. We'll see how it goes. So S is 16 -4 equals 4 lots. I'm going to put the 4 at the front of -2.5 plus a half. Again, I'm just going to put the t to the front, a number, and then I'm going to call it ax and ay. It doesn't really matter if you just kind of leave it as a or an empty vector or whatever you want. And I'm going to rearrange to get the ax and ay on its own. So we're going to have 16 and -4 is going to equal to, so what we've got here, so -8 and 20. And so 4 squared 16 half 8, so 8, so add 8 lots of ax and add 8 lots of ay. But I can kind of get rid of effectively the brackets, but I'll keep it consistent. Right, if I solve this top line, it's an arrow by the way. 8x, so add on the 8, so 24 divided by 8, so 3, so ax should equal to 3. -4, that says, by the way. Believe it or not. Take away 20, it'll get a bit messy now. So -24, so -3. So I've now got 3 minus 3 for my acceleration. So my A is 3 minus -3. My mass is 2.4 kilograms. So I'm going to use F equals ma. So my force is going to equal to 2.4 times by that vector. Fairly straightforward at the end. Okay, 7.2, -7.2. Put my units in there as well for newtons. Okay, fairly straightforward at the end, at least.